Okay, so in the world of AI, getting a single confident answer is one thing. But what if an AI could tell us how sure it is of that answer? Today we're going to dive into some really fascinating research that creates a powerful team-up and alliance between two AI systems to do exactly that. It's all about making AI predictions more reliable and, frankly, more trustworthy than ever before.
I mean, really think about that for a second. When you ask a human expert a really tough question, they almost never give you just one exact number, right? They'll say something like, well, it's probably between this and that. That ability to show uncertainty, that's a huge sign of intelligence. And honestly, it's a critical missing piece for a lot of AI systems, especially when the stakes are really, really high.
So there's actually a technical term for this range of uncertainty. It's called a prediction interval. It's a simple idea, but it's so powerful. Instead of demanding an AI predict the temperature will be exactly 75 degrees, we ask it for a probable range, like, hey, I'm pretty sure it'll be between 72 and 78. This one little shift is the absolute key to building AI we can actually count on.
But, just creating a range isn't quite enough. This is where we run into something called the confidence problem. See, a prediction has to be more than just statistically correct. It has to be genuinely useful in the real world. Just take a look at this example. An AI telling you tomorrow's temperature will be between 10 and 140 degrees. I mean, sure, it's technically valid. It's almost certainly going to be right, but it's completely useless for deciding if you need to wear a coat, right? What we actually need is a high-quality prediction, one that's not only valid but also has a nice, narrow, precise range that's actually helpful. So the real goal here isn't just about being correct. It's about getting these high-quality, super tight intervals.
So how in the world do we get there? Well, this is where two researchers, Msaddi and Kumbasar, came up with a brilliant team-up. They call it the Alliance. And it's all about bringing together two totally different AI approaches, each with its own unique skills to solve the problem together.
First up, we have the intuitive expert. Now, the technical name is a Type 2 fuzzy logic system, but its special power is handling ambiguity. It doesn't just see temperature as a number, it thinks in overlapping ideas, like cold, cool, warm, and hot. This makes it awesome at understanding messy, real-world data, but it has one little weakness. It can't give you a strict mathematical guarantee of its accuracy.
And that's where our second hero comes in, the statistical referee, also known as conformal prediction. Think of this as a strict, impartial rulebook that you can apply to any prediction model out there. Its job is simple, to provide that missing mathematical guarantee. It doesn't make the first guess, it just makes sure the final range is statistically solid.
And here it is, straight from the researchers themselves. This is their mission statement. They're integrating the intuitive expert with the statistical referee to use the best of both worlds. The goal? To generate those high-quality prediction intervals we've been talking about.
Okay, so we've met the team. How does this alliance actually work in practice? Well, it's a pretty clever three-step process where each partner has a very distinct and super important role to play. It all breaks down into three phases. First, the intuitive expert gets trained on a bunch of data to learn the basic patterns. Then comes the crucial second step, calibration. The statistical referee watches the expert make predictions on a different set of data. It carefully measures the mistakes, basically figuring out a correction score based on how wrong the expert tends to be. And finally, it's prediction time. The expert makes its best guess, and then the referee steps in, using that correction score to adjust the final range, guaranteeing it hits that 95% confidence target we need.
It's a great theory, for sure, but does it actually work in practice? Well, the researchers put their alliance to the test. They benchmarked it against other models to see if this team-up was truly the breakthrough they thought it was.
Now, to judge the winner, they use this metric called the coverage with criterion, or CWC. It's basically a single score that captures our two big goals perfectly. First, it dings any model that doesn't hit the 95% accuracy target, but if it does hit the target, it rewards the model that has the narrowest, most precise interval. So all you really need to remember is this: a lower CWC score is better, much better. And the results? They were pretty dramatic. On the classic Boston housing dataset, other models got an average CWC score of about 1.17. The Alliance? It scored a 0.53. Now that's not just a small improvement, that's more than twice as good. It delivered a prediction that was just as valid, but massively more precise. And this wasn't some fluke. They tested it across multiple datasets, and the story was the same every time. The Alliance proved itself to be a really robust framework that consistently nails the ultimate goal, creating predictions that are both statistically reliable and tightly focused enough to be incredibly useful.
So what does all this mean for the future? Well, it's about way more than just better data points. It's about building an AI that is fundamentally more trustworthy.
And I mean, think about the high-stakes fields where we're already using AI. For a self-driving car, knowing the potential range of where a pedestrian might move is so much more important than knowing their single most likely spot. Or in medicine, a diagnostic tool that gives a confidence interval for its findings, that lets doctors make much better, more informed decisions. This isn't just some academic exercise. This is a critical step for safety and reliability.
And ultimately, that is the key takeaway here. Trust isn't built on an AI that pretends to be right all the time, because no system ever is. Real trust is built on an AI that understands and can clearly communicate its own limitations. This alliance framework is a huge step in that direction. It gives AI a credible voice to finally say, you know what, I'm not exactly sure, but I'm 95% confident the answer is in this range.
So this breakthrough really proves that we can build AI that's more honest about what it doesn't know. And that leaves us with a really fascinating question to chew on. Now that we can build more reliable AI, what are the next huge challenges in science, in engineering, in medicine that we should finally have the confidence to go out and tackle? Thanks for joining this explainer.